Hello and welcome to this GLOBEClaritas video on what's new in version 6.9. This new latest stable release was dispatched to clients last week, and I'm just going to basically give you some overviews on some of the new functionality in the software for this release. And I'm going to start by showing off some functionality within the Griffin application. Now there's already a video out there for Griffin itself, but this is just to give you, those who haven't seen it, a little idea of what the application can do. So if I go to the seismic data tab of the launcher and click on the trace header maths button, and it'll bring up a selection widget to pick a file. Now Griffin only works on HDF5 datasets because it has the ability to interact with and update trace headers on the fly, and also write new trace headers as well as updating existing ones. So I'm going to pick the GNS Job 2 HDF5 dataset, and basically to show how the application works, I'm going to use the scripts button. But first I'm just going to show you what you can do with some simple stuff. So we can do very basic header math updates like source num header equals record num header, or channel equals ftrace, or again shot ID equals record num. And if so first thing you need to do is evaluate or make sure that your expression is correct and acceptable. So you click that, it evaluates OK. It now allows you to save the information into the trace header as well. So we click on Save Headers to save that, and then we're going to click on the scripts button. And you can see in here that there are a number of scripts available for you to choose from. We've got the create crossbred gathers, which is a bit of a test expression, but welcome to play around with it and give some feedback as to whether it's working as you expect in terms of creating crossbred headers, setting the midpoint coordinates, or set simple marine CDP offsets. So we're going to use the set simple marine CDP offset, so i.e. apply a basic 2D marine straight line geometry to a data set. So if we open that expression, you can see that basically we get some new information put in here, replacing what we'd already done. So basically what this does is take some key information in some existing headers, so coordinate scale, source num, channel, and then basically updates and creates CDP offset, source X, rec X, and CDP X. Now the rec X, source X, CDP X headers, when they're created, are grid coordinates, not real world, so that's something to remember. And basically it uses a bunch of constants that the expression then uses in its mathematical function to generate the CDP and offset information. So we need to define the shot spacing, which on our standard marine 2D tutorial is 25 meters. Receiver spacing is 25, CDP spacing of 12.5, and near offset is actually 258. And near channel on this dataset is 120, and our maximum number of channels again is 120. So our near channel is on our highest channel number, so it's just worth remembering. And then basically we have a whole bunch of maths in here that creates the information we need into the seismic trace headers. And you can see here one of the other things that this application uses is, or can access, the numpy scipy functions. And you can see where we're using numpy functions. That's defined by this mp.round function call here. So again, we need to just quickly evaluate that the header's working fine. We can then click on Save Headers, again to update the seismic trace header. If we list the header details, basically it will tell us all the trace headers that have been touched by the application when it's been run. So we can see we've updated CDP, CDPX has been modified, channel and coordinate scale have been used, offset's been modified, rec X has been modified, shot ID and source number have been used, and the source X has been modified. So that's showing us what headers we've interacted with that expression. We can list the header values, so I look at what how the headers are after the application expressions run. So we can see that the offsets are what we're expecting. So on our channel 1 we've got our far offset, and if we scroll down you can see on channel 120 of that first shot our near offset is 258. And then we can as well, if we want, display the headers we've updated by clicking on the View Seismic button. And that brings up a SV application, and we can basically, for instance, overlay the offsets. So we can see that the offset on this data is tracking in the right direction from our near offset on our highest channel number through to our farthest offset on our smallest channel number on this data. So this means basically for something like 2D geometry, you no longer have to run a seismic processing flow. You can do it all interactively in the Griffin application, and then basically check and QC and make sure your geometry is applying correctly. No need to create a new data set for applying the geometry, and makes life very, very simple. So click rid of that. So the next thing I would like to show you is a new surface noise or ground roll attenuation module that's available in this release of Claritas. So I'm going to go to the job files and select the 05 denoise job from the 6.8 land tutorial that will hopefully be coming out soon. And you can see basically in there we have a module called Slaught, which stands for surface noise attenuation in the wavelet transform. So if I open that up, if you're familiar with the DU swell module, you'll see the parameterization is very similar. So we define the maximum fold, a threshold value at the top and bottom, so anything that exceeds this threshold amount will be considered to be noise and will be attenuated, and then those frequencies reinterpolated back in. And then we also define basically a spatial and temporal window in which the data is analysed. And then we can basically define how many of those amplitudes within that window are to be used for the basis of the threshold calculations. So basically it splits the data up into different octaves within the wavelet transform. That isolates the noise nicely, and then we can basically hopefully remove it using the Slaught module and come out with data that's had some significant improvement in terms of surface noise. So I'll show you an example we have on this 3D land tutorial data set. I'll go to View Seismic, and we've got basically data with and without Slaught. And basically I will move along to the point at which we actually have some data. We'll just put a whole trace balance on this data set, so it'll help us visualize what's going on. Move along to where we've got some noise that we can look at. So there you can see some fairly obvious ground roll or surface noise. It looks a little ugly, a little aliased. So that's data after the surface noise attenuation. So we're not removing everything, and there's probably an argument that we could improve the parameterization on this data set, but we're certainly attenuating it quite significantly. And considering the data is quite heavily aliased, it's showing that Slaught works quite well. There's no need to interpolate additional traces in to try and unwrap the aliasing. So it's looking at a fairly good result on this data set. Maybe could be better, but at this sort of stage I'm quite happy. And obviously there is the argument that if you wanted to have another go at this noise, maybe by reorganizing the data into common receiver domain or something like that, and then applying a Slaught module again, might isolate that energy even better, and i.e. to take some more out at that point. So that's all I've got to say on that surface noise attenuation application. So next I'm going to discuss some new functionality in the 3D RefStat and SV applications. So in the last release of Claritas version 6.8, we connected up the SV application and the 2D RefStat to allow improved QC QA of first break picks, update, and then feeding those updates of any picks back into the refraction statics application itself. Now we've connected that same functionality up to 3D RefStat, and I'll basically just show you how that works. Click on the 3D RefStat button. We're going to select the O2 AddGeom file as our input. Click OK. And that basically brings up the RefStat application interface. So we can see the Teapot Dome datasets geometry in there, and our overlaid velocity profiles or interfaces. So you can now see basically that we have a new button on this application, which is the View Seismic. So if I click on that, it'll load basically the seismic data. And then basically I can then move on to where I actually have some seismic and some pics available. You can see the pics there. So what I can do basically is go in and I can either make some manual updates to these pics. So just to show you, I can go through there and add some pics and update them. I can then right mouse button click, and basically you see now that the reload button has now become live on the RefStat application. So I click on that, it'll then basically load in those updated pics and hopefully give me an improved refraction static solution with those updated pics. One other thing I'll show you in the 3D refraction, in the SV application, is we now have an unpick button for first break pick. So if you've got a bad trace or a trace that you don't think should have a first break pick on it, you can now click on the unpick button and basically go to the trace you don't like, and it'll basically remove that pick and clear the trace header in the data set as well, so that you won't have anything showing up in there or a pick in there that might distort or provide an issue for your 3D refraction statics analysis. So again, works the same pretty much as the 2D RefStat application, but it's just rolling that functionality out across the 3D RefStat as well. So again, as with the 2D RefStat, go away, test it, try it and see how it performs, but we think it should give you a valuable improvement on the application. So I'll exit out of that application and out of SV. And the next bit of functionality I'm going to show you is around some improvements to the GUI. So what we've just basically tried to do with this is when you're looking to pick a shift file or a mute file or an NMO file, previously or in our current setup in 6.8 and prior, when you selected a data set, so if we go to a job file and say we'll pick the 04 refract stack as an example job, and basically say we go to static and we want to select a static file to apply. When you clicked on the list button previously, you would get a list of every static shift file existed within the data set. Now if we click on that, basically initially you'll be given a shorter list which will show you either the shift or NMO files, etc., that have been applied or used or created from the input HDF5 dataset. So it sort of shrinks that list down, gives you fewer to select from. Hopefully what you're looking for is in that shortened list. If it's not, then basically all you have to do to get the full list is click on select from file dialog, and you'll get the full file list with every shift file or NMO file in the dataset or in the project that you're working on. So hopefully that makes life a little easier, slims down what you're looking at, but still gives you the flexibility to go and search through the entire project for a particular file that you might need. So that's all I'm going to say about that. Very simple, easy thing to talk about. There's obviously a whole bunch of other improvements to Claritas, which you can find by going to the help file and then clicking on release notes text or release notes HTML, and that'll basically give you a full rundown of all the updates, improvements and bug fixes that are available in 6.9. Now the last thing I'm going to talk about in terms of this release is not really a development for the release, but more something we tested and confirmed worked, is around use of Claritas with the Windows subsystem for Linux capability that's available in Windows 10. So just to give you an idea, the entire demonstration we've run in this version 6.9 What's New has been run using the Windows subsystem for Linux, and in this case we're running using the 6.9 release on an Ubuntu Linux running as a subsystem of the Windows operating system. So basically what it is, we have some instructions on how to set this up and install the subsystem, and then how to install Claritas on that. So if you contact the support desk, they can send you those instructions through. But basically, once you've got it installed and up and running on Windows 10, effectively what you get is this icon here, Bash on Ubuntu on Windows. You click on that, that opens up a sort of an X-terminal screen like this, from which you can then fire up the Claritas launcher. So if I click on the miscellaneous and show you the system info for this, basically comes up and reports to you that you're running GLOBEClaritas 6.9.1 release on Ubuntu 16.04 in this case. So the flavors of Linux that are available are that you can use Claritas on this subsystem at the moment, I understand, are Ubuntu 16 and Ubuntu 18.04 long-term supports, both of which are supported with Claritas. And again, what that opens up for you is the option to basically start using the version selector and being able to install betas alongside your stable branch if you're running in the Windows system, something that's been available for Linux users for a long time, but now opens that up to a Windows environment if you're running Windows 10, this subsystem. So we can basically then flick between a production release and a development release of Claritas. Allows you to get immediate access to new functionality that's coming out in the beta releases, rather than having to wait for the full stable release of the software for a Windows environment. That's all I've got in terms of new functionality and capability I want to demonstrate in this release. Any questions, contact Claritas support, and hopefully you find this new release very valuable. Thank you and goodbye.